Data science has been one of the major driving forces behind the explosion of Python in recent years. It's now used for AI research, it controls some of the most powerful telescopes in the world, it tracks crop growth and prediction, and so much more. But with all this growth, there's an explosion of data science and machine learning libraries. That's why I invited Pete Garcin onto the show. He's going to share his top 10 machine learning libraries for Python. After this episode, you should be able to pick the right one for the job. This is Talk Python to Me, recorded July 20th, 2017. Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode is brought to you by DataCamp and us right here at Talk Python Training. Be sure to check out what we're both offering during our segments. It really helps support the show. Pete, welcome to Talk Python.
Thanks. I'm happy to be here.
Yeah, it's great to have you here. And I've done a few shows on machine learning and data science, but I'm really happy to do this one because I think it's really accessible to everyone. We're going to bring all these different libraries together and kind of just make people aware of all the cool things that are out there for data science and machine learning.
Yeah, it's really crazy actually how many libraries are out there and how active the development is on all of them. There's new contributions, new developments all the time. And it seems like there's new projects popping up like almost daily.
Yeah, it's definitely tough to keep up with. But hopefully this adds a little bit of help for the reference there. But before we get into all these libraries, let's start with your story. How did you get into programming in Python?
I started programming at a pretty young age, like sort of back before Stack Overflow and things like that existed. And I sort of mostly made games. I started with BASIC, like most people probably from a certain age. And then working on Pascal and was making games for my BBS back in the day, making online games, utilities and stuff like that. And then for Python, later when I worked in games for a long time. And when I worked in games, we were doing like tool automation, so like build automation, certain workflow automation, build pipelines, all that kind of stuff. So Python was a tool that we used quite a lot there. So that was where I got my start with Python.
Oh, yeah, that's really cool. Python is huge in the workflow for games and movies, way more than people on the outside realize, I think.
Yeah, especially for artists. So like a lot of the tools have Python built into them. And so artists will use it for like automating model exports or rigging and that kind of stuff. So it's pretty popular in that sense. And then also still even just for like building assets for games. Okay, I'm intrigued by your BBS stuff.
It occurs to me, and it's kind of crazy, there may be younger people listening that don't actually know what a BBS is.
Okay, so a BBS is short for Bulletin Board System. And it was sort of like, in a way, the precursor to the internet, where you used to host what is effectively sort of a website on your home computer, and people would like call your phone number and you'd have it hooked up to your modem, and they would like call your phone number, connect to your home computer. So in my case, it was like my computer that I played games on and did my homework on and that kind of stuff. And they could connect and send messages to each other and download files and play games, very simple games, that kind of thing. So it was like
yeah, it was so fun.
Yeah, it was awesome. And like, I really, really enjoyed it. And you had a thing called like Echo Mail back then, which was like this sort of way of like transferring messages all over the world. So, you know, somebody would send a message on your BBS and then it would like call a whole bunch of others like in this network. And then somebody in like Australia might answer it. And it would take like days to get back because it would be like this chain of people's BBSs calling the next one. So
yeah, there was no internet. It was the craziest thing. Like we at our house, my brother and I had talked my dad into getting us multiple phone lines so we could work with BBSs like in parallel. And you would send these mails, and like at night there would be like a coordination of the emails across the globe as these things would like sync up the emails they got queued up. It was the weirdest thing, but I loved, I don't know, was it Trade Wars or Planet Wars? One of those games. I really loved it.
For sure. I'm like a huge Trade Wars fan. You can actually play it now. Like there are people who have it set up on like websites that have like simulated telnet stuff, and you can play versions of Trade Wars, which I have done recently just to like...
Don't tell me that. You're going to ruin my productivity for like the whole day.
Yeah, after this, you'll be like, oh, Trade Wars 2002, it's still around. People still play it. But it was such a good game. It's fantastic.
Yeah, it was fantastic. It's awesome. All right, so that's how you got into this whole thing. Like, what do you do today? You work at ActiveState, right?
I do, yeah. I'm a dev evangelist at ActiveState, so generally that means working with developers, language communities, trying to make our distributions better. So at ActiveState, we do language distributions. Probably a lot of people in the Python space know us that we do ActivePython, and it's been around for a long time. We were founding member of the Python Software Foundation. And so ActiveState has a pretty long history in the Python community. And before that, people probably know us from Perl, and now we have Go distribution and Ruby beta coming out soon. So we're sort of expanding to all these different dynamic language ecosystems.
Sure. That's awesome. So I know that maybe people are a little familiar with some of the advantages of these higher order distributions for Python, but maybe give us a sense of like, what is the value of these distributions over like going and grabbing Go or grabbing Python and just running with that?
I think that you've got obviously this sense of curated packages. So there are, in the Python distribution, there's like over 300 packages. And so that they're going to build, know they're going to play nice with each other, know that they have current stable versions, all that kind of stuff. And then additionally, you can buy commercial support. So for a lot of our customers, so we have a lot of like large enterprise customers, they can't actually adopt a language distribution or a tool like that without commercial support. They need to know that somebody has their back. And so that's something that we offer on these language distributions for those large customers. But for the community and for individual developers, then that is something that having that curated set of packages that is going to work, that is going to play nice, and that also as maybe a development team lead, you might want a unified install base so that all your developers have the same development environment and it's all going to play nice. And so that's one of the advantages of those.
That's really cool. Certainly the ability to install things that have weird compilation stuff. Do you guys ship the binaries like pre-built for that? So I don't have to have like a Fortran compiler or something weird?
Exactly, yes. So they're all pre-built, all pre-compiled. So, a lot of people, depending on what platform you're on, like on Windows, might not even have a C compiler installed, and a lot of packages are C-based. And so they're pre-built. And like you said, you don't need a Fortran or compiler or some exotic build tool to actually make it work. It just works out of the box. Yeah.
Okay, that's really awesome. And ActivePython is free? If I'm like a random person, not a huge corporate that wants support?
Exactly, yeah. If you're just a developer, it's free to download and free to use. And even if you are a large corporation, it's free to use it in non-production settings, so on your own. So it's you can go and just download it, try it out, see if it works for you.
Okay, yeah, that sounds awesome. How many of the 10 libraries we're going to talk about would come built in? Do you know off the top of your head?
I think that actually almost all of them, but maybe I think Cafe is on the list. It's not in the current one, but it is on the list to be included. So I think actually like pretty much all of the other ones, maybe CNTK as well is.
Yeah, that's really new as well.
That's really new. So, but we are targeting to have as many of these as we possibly can. And so pretty much most of them are included.
That's awesome. So all the libraries that we're talking about, like one really nice way to just get up to speed with them would be grab ActivePython and you'd be ready to roll.
Exactly. Yeah.
Awesome.
Grab them, install them. You're ready to roll right out of the gate.
Cool. All right. So let's start at what I would consider the foundation of them. The first library that you picked, which is Numpy and SciPy.
Absolutely. And they are foundational in the sense that a lot of other libraries either depend on them or are in fact built like on top of them, right? So they are sort of the base of a lot of these other libraries. And most people might have worked with NumPy. Sort of its main feature is that sort of n-dimensional array structure that it includes. And a lot of the data that is shipped to a lot of the other libraries is either supported that you can send it a NumPy array, or it requires that you format it that way. So especially when you're doing machine learning, you're doing a lot of matrices and a lot of like higher dimensional data, depending on how many features you have. It's a really, really useful data structure to have in place.
Yeah. So NumPy is this sort of array-like, multi-dimensional array-like thing that stores and does a lot of its processing down in a C level, but has, of course, its programming API in Python, right?
Yes, yeah, exactly. And a lot of these machine learning libraries do tend to have C level, like lowest level implementations with a Python API. And that's predominantly for speed. So when you're doing tons and tons and tons of calculations and you need them to be really, really lightning fast, that's the primary reason that they do these things, sort of at the C level.
All right, absolutely. And so related to this is SciPy. They're kind of grouped under the same organization, but they're not the same library exactly, are they?
No. So SciPy is like a more scientific mathematical computing thing. And it has the more advanced like linear algebra and like Fourier transforms, image processing. It has like a physics calculation stuff built in. So most like scientific numerical computing functionality is built into SciPy. I know that Numpy does have like linear algebra and stuff in it, but I think that the preferred is that you use SciPy for all that kind of linear algebra crunching.
Okay, yeah. So a lot of these things that we're going to talk about will somewhere in them have as a dependency or an internal implementation of some variation, or even maybe in its API, like the ability to pass between them these NumPy arrays and things like that.
Absolutely.
Yeah. One other thing that's worth noting that's pretty interesting, and I think this is a trend that's growing. Maybe you guys have more visibility into it than I do, but NumPy in June 13th, 2017, so about a month ago at the time of the recording, received a $645,000 grant for the next 2 years to grow it and evolve it and keep it going strong. That's pretty cool.
It is very cool. And I think that you're starting to see that these open source projects are really forming the backbone of most of the machine learning research and actually implementation that you're seeing out there in the world. There's not a lot of sort of more closed source behind trade secret stuff. A lot of the most bleeding edge development and active development is happening in these open source projects. So I think it's great to see them receiving funding and sponsorship like that.
Yeah, I totally agree. And it's just going to mean more good things for the community and all of these projects. It's really great to see. One thing I want to touch on for every one of these is to give you a sense of how popular they are. And for each one, we'll say the number of GitHub stars and forks. And that's not necessarily the exact right measure for the popularity, because maybe this is used, like obviously NumPy is used across many of these other things which have more stars, but people don't necessarily contribute directly to NumPy and so on. But for NumPy, NumPy has about 5,000 stars and 2,000 forks to give you a sense of how popular it is. The next one up, Scikit-Learn, has 20,000 stars and 10,000 forks. So tell us about Scikit-Learn.
Scikit-Learn is again, like we mentioned before, is a thing that's built on top of SciPy and NumPy, and is a very popular library for machine learning in Python. And I think it was one of the first, if not the first. I'm not 100% sure, but it's been around for quite a long time. And it supports a lot of the sort of most common algorithms for machine learning. So that's like classification, regression tools, all that kind of stuff. I actually just saw like a blog post come up in my feed today where Airbnb was using Scikit-Learn to do some kind of like property value estimation or something using machine learning. So it's being used very, very widely in a lot of different scenarios.
Oh yeah, that sounds really cool. It definitely is one of the early ones, and it's kind of simpler in the sense that it doesn't deal with all the GPUs and parallelization and all that kind of stuff. It talks about classification, regression, clustering, dimensionality, and modeling, things like that, right?
Yes, that's right. It doesn't have GPU support, and that can make it a little bit easier to install if sometimes the GPU stuff can have a lot more dependencies that you need to install to make it work, although that's getting better in the other libraries. And it's, like you say, it is made and sort of designed to be pretty accessible and pretty easy, because it has the sort of baked in algorithms that you can just say, oh, I want to do this, and it will crunch out your results for you. So I think that that's sort of the sort of ease of use and the sort of cleanliness of its API has contributed to its sort of longevity as one of the most popular machine learning libraries.
Yeah, absolutely. And it's obviously Scikit-Learn being part of the SciPy whole family. It's built on NumPy, SciPy, and Matplotlib.
Yes. So it includes interfaces for all that stuff and for like graphing the output and using Matplotlib and using NumPy for inputting your data and for getting your data results, all that kind of stuff.
Yeah, very cool. All right, next up is Keras at 17.7 thousand stars and 6,000 forks. So this one is for deep learning specifically, right?
Yeah, and so this is for doing rapid development of neural networks in Python. It's one of the newest ones, but it's really, really popular. I've had some experience working with it directly myself, and I was sort of really, really blown away by how simple and straightforward it is. So there's like, it creates a layer on top of lower level libs like TensorFlow and Theano, and lets you just sort of define, I want my network to look like this. So I want it to have this many layers and this many nodes per layer. And here are the activation functions. And, here's the optimization method that I want to use. And you sort of just define this effectively a configuration, and then it will build all of the graph for you, depending on what backend you used. And so it's very, very easy to experiment with the shape of your network and with the different activation functions. So it lets you kind of really quickly reach and test, different models to see which one works better and to sort of see what one works at all. So it's really easy to use and really very effective. I used it to build a little game demo where we had an AI where I trained an AI to play against you to determine when it could shoot at you.
Was this the demo you had at PyCon?
It is, yeah. And so we had that demo at PyCon. I since did a blog post about it a little bit. And then I actually just recently rewrote it in Go for Con too. So eventually it will be open sourced so that people can see. But one of the things that you really notice is that the actual code for Keras to basically define the network and do the sort of machine learning heavy lifting part is very, very minimal, like a dozen lines of code or something like that. It's really surprising because you think it's like a ton of work, but it makes it super easy.
Yeah, that's really cool. And it sounds like its goal is to be very easy to get started with. I like the idea of the ability to switch out the backends from, say, TensorFlow to CNTK to Theano. How easy is it to do that? Like, could I run some machine learning algorithms and say, let's try it in TensorFlow and say, do some performance benchmarks and stuff? No, let's switch it over to Theano and try it here and kind of experiment rather than completely rewrite it in those various APIs.
Exactly. It's just a configuration thing. So it's almost like a tick box, essentially.
That is so easy.
It's so easy. And so that is absolutely one of the driving key features of that library, that you can just pick whichever one suits your purpose or your platform, depending on what's available on the platform that you're building for, because currently there's not TensorFlow versions for every platform on every version of Python, all that kind of stuff. So.
Right. Okay. Well, that's pretty cool. So there's two interesting things about this library. One is the fact that it does deep learning. So maybe tell people about what deep learning is. How does that relate to standard neural networks or other types of machine learning stuff?
Well, I think the simplest way to put it is the idea of adding these additional layers to your network to create a more sophisticated model. So that allows you to create things that can take more sophisticated feature domains and then map those to an output more reliably. So, and that's where you've seen a lot of advances, for instance, in a lot of the image recognition stuff that leverages deep learning to be really, really good at identifying images, or even doing things like style transfer on images, where you have a photograph of some scene and then you have some other photograph and you're like, I want to transfer the style of the evening to my daytime photograph, and it will just do it, and it looks pretty normal. And those are the most, I guess, popular, common deep learning examples that you see cited.
Yeah, that makes a lot of sense. And it's easy to think of these as being Snapchatty, sort of superfluous type of examples. but, machine learning doing them, like, putting the little cat face on or switching faces or whatever. But, there's real meaningful things that can come out of this. Like, for example, the detection of tumors in radiology scans and things like that. And these deep learning models can do the image recognition on that and go, yep, that's cancer, maybe better than even radiologists can already. And then in the future, it's going to get crazy.
Exactly. And it's funny you mentioned that. Stanford Medical about a month and a half ago, actually released I don't know how many, 500,000 radiology scans that are annotated and ready for training machine learning. So that exact use case is intended to be a deep learning problem to be applied. And there are all kinds of additionals of these data sets that are coming out. I just saw a post this week about deep learning model that was measuring heart monitor data and being more effective than cardiologists, kind of thing. So
it's really crazy. You think of this AI and automation disrupting low-end jobs, right? At McDonald's, we might have robots making our hamburgers or something silly like that. But if they start cutting into radiology and cardiologists, and that's gonna be a big deal.
It absolutely is going to be a big deal. I think people probably need to start thinking about it. I don't think it's necessarily a complete replacement thing. It's not, the radiologist AI can't talk to you yet, yeah. I guess, and until wait till we get to NLTK. But it can definitely augment and lighten the load on professions like medicine that are, perpetually overworked, and allow them to be more effective, human doctors. So I think that as tools, these things are going to be absolutely incredibly revolutionary.
Yeah, it's going to be amazing. Do you want a second opinion? Let's ask the super machine.
Yeah, exactly. But I mean, it's able to, one of the strengths of all these machine learning models is that the machine learning models are able to visualize higher dimensional complex data sets in ways that humans can't really do. And they have just intense focus, I guess, right? These models. Whereas it's pretty hard for a doctor to read every single paper ever written on subject X, or to look at 500,000 radiology images even across the course of their career. So
pretty optimistic where this goes. It's going to be interesting to join all this stuff together. The other thing that we're just starting to touch on here, and it's going to appear in a bunch of these others, so maybe worth spending a moment on as well, is Keras lets you basically seamlessly switch from CPU computation and GPU computation. So maybe not everyone knows the power of non-visual GPU programming. Maybe you could talk about that a bit.
For sure. So your GPU, which is your graphics processing unit. So, if you have a gaming PC at home and you have an NVIDIA graphics card or an ATI graphics,
can run the Unreal Engine like crazy or whatever, right?
Exactly. So if you play games and you have a dedicated graphics card, even without a dedicated graphics card, but you have a GPU, and there's this thing called general purpose GPU programming, so that originally, a GPU is highly parallel computer. It has 1,000 cores in it or whatever, some huge number of cores.
Yeah. 1 to 4 or 5,000 cores per GPU, right?
Exactly.
Insane.
Yeah. And so the intention there was originally that it's because it needs to in parallel process every pixel or every polygon that's going on the screen, right? And perform effects. So that's why you can get blur and all this kind of stuff in real time, and real time lighting and all that kind of stuff. So it processed all that stuff in parallel. But then as the people started to develop SDKs that let you in addition to doing graphics programming, we can just run regular programs on these things. And they're really, really fast at doing math programs. So we can do that. And so now basically a lot of these libraries support GPU processing, and it's literally just a compile flag now. It's getting a lot easier. You still have to make sure you have the drivers and that you have a GPU that's reasonably powerful, and especially if you're doing a lot of computation. And so then you can basically run these giant ML models on your GPU. And again, it's something that's pretty well suited to being parallelized. So that is really great use of GPU. And that's why you're seeing it take off, because these models are are easily made parallel.
Yeah, they're what are called embarrassingly parallel algorithms, right? And just throw them at these things with 4,000 cores and let them go crazy. Yeah, the early days, I mean, still, I guess, when you're doing DirectX or OpenGL or these things, like it's really all about, I want to rotate the screen. So that's like a matrix multiplication against all of the vector things in there. It's really similar, actually, the type of work it has to do. The other thing, I guess, which I don't see appearing anywhere in here, but I suspect TensorFlow may have something to do with it, is the new stuff coming from Google where they have like going beyond GPUs for like AI focused chips. Did you hear about this?
Yeah, so Google has a thing called a TPU, which is a tensor processing unit or whatever. And that's like a cloud hosted special piece of hardware that's optimized for doing TensorFlow. And so I don't know the exact benchmarks in terms of how that compares to, like some gigantic GPU assembly. But obviously Google thinks that this is a worthwhile investment to build these sort of hardware racks in the cloud and then give people access to run their models on there. So I think you're probably going to see more and more specialized ML targeted hardware that's coming out. I don't know whether it's like you'll also see consumer hardware, like you can go and buy something for your home computer, but especially in the cloud, you definitely will.
Yeah, definitely in the cloud. Yeah, it's very interesting. They were talking about real-time training, not just real-time answers. So that sounds pretty crazy. This portion of Talk Python to Me has been brought to you by DataCamp. They're calling all data science and data science educators. DataCamp is building the future of online data science education. They have over 1.5 million learners from around the world who have completed 70 million DataCamp exercises to date. Learners get real hands-on experience by completing self-paced, interactive data science courses right in the browser. The best part is these courses are taught by top data science experts from companies like Anaconda and Kaggle and universities like Caltech and NYU. If you're a data science junkie with a passion for teaching, then you too can build data science courses for the masses and supplement or even replace your income while you're at it. For more information on becoming an instructor, just go to datacamp.com/create and let them know that Michael sent you. So speaking of popular libraries and TPUs, the next up is TensorFlow. That originally came from Google, and it is crazy at 64,000 stars and 31,000 forks. So tell us about TensorFlow.
So TensorFlow, obviously, this is Google's machine learning library, and this forms the sort of slightly lower level than something like Keras, and like obviously it's used as a back end. You can use it directly as well, and what it does is it represents your model as a computation graph. So that's effectively a graph where the nodes are like operations, and this is a way that they found is really, really effective to represent these models. And it's a little bit more intimidating to get started with, mostly because you have to think about building this graph. But you can use it directly in Python. Python's actually the recommended language and workflow from Google. So, for example, when I rewrote the Go version of our little game there, I still had to train and export my model from Python. So I used Python to build that, export it. So that's the sort of recommended workflow currently from Google for many languages, is to use Python as the primary language binding.
Yeah, that's really interesting and great to see Python. Python appears in so many of these libraries as a primary way to do it. So there's some interesting stuff about this one. Obviously, it's super popular. Google has so many use cases for machine learning just up and down their whole, everything that they're doing. So having this like developed internally is really cool. It has a flexible architecture that lets it run on CPUs or GPUs, obviously, or mobile devices, and it even lets it run like on multiple GPUs and multiple CPUs. Do you have to do anything to make that happen, or do you know how it does that?
As far as I can tell, that especially for like this switching between CPU and GPU, it's essentially a compile flag. So you have to build, like when you build the libraries or download one of the nightly builds or whatever, you have to get one of the versions or that has the enabled GPU support kind of thing built in. And I think that there are also now increasingly like CPU optimizations in there. So like, for instance, Intel is doing hand optimized math kernel stuff that's integrated directly into TensorFlow to make it even faster. So that's something that you can also get in like the latest version as well. So I definitely think speed and performance and making that stuff easily accessible to, depending on what your hardware is and where you're going to deploy it, is a big focus for them.
Yeah, that's really cool. So do you think this is running in the Waymo cars, the Google self-driving cars?
I mean, I don't know for sure, but I would be almost positive of it. From everything that I've read and people that I've talked to, I mean, Google built this to use, not just, so this is their platform for all of their deep learning and machine learning projects. And so I would assume that that's TensorFlow is powering that, and it's running pretty much all of their stuff.
Very, very cool. It's probably in Google Photos and some other things as well.
Yeah, Google Translate, all those things are all, those things, pretty much all of the projects, when you start looking at them that Google is running, are all effectively AI projects. And that's basically all the things that, that just recently, like the Google Translate, which uses machine learning and like statistical models to do the translations, is approaching human level accuracy for translation between a lot of the popular languages where they have huge data sets to pull from.
Yeah, that's crazy and very, very cool. So up next, number 5 is Theano at 6,000 stars and 2,000 forks. And this one is really kind of similar to TensorFlow, but really low level, right?
Yeah, so it is, more low level, and it is very similar to TensorFlow in the sense that it's also a very high speed math library. And I believe it was originally made by a couple of the guys who then went on to Google to make TensorFlow. So it predates TensorFlow by a little bit, but it also has, the things that we're talking about here. It has transparent GPU use, and you can do things like symbolic differentiation and a lot of like mathematical things, mathematical operations that you want to be highly performant. So it is actually pretty similar to what TensorFlow does and sort of serves a similar purpose, but depending on what you're comfortable with and what your maybe existing projects are, then that is probably going to dictate which one you're using. And if you're using something like Keras, then you can just choose this as the back end. And
just flip the switch.
Just flip the switch and there you go.
Yeah, it's cool. It also says it has extensive unit testing and self-verification where it'll detect and diagnose like errors. Maybe you've set up your model wrong or something like that. That's pretty cool.
That's pretty cool. Yeah, for sure. I mean, all of these libraries are built by super smart, accomplished people who are creating things that are, solving a real world problem for them and really, sort of pushing things forward. And I actually think it's great that there's so many libraries in this space, because it really is just making it better for everybody.
Yeah, the competition is really cool too, to see the different ways to do this and probably cross-pollination.
Exactly.
Yeah. So one of the things you have to do for these models is feed them data, and getting data can be a super messy thing. And the one library that stands out above all the others about taking, transforming, redoing, cleaning up data is Pandas, right?
Absolutely. Yeah. Pandas is one of those libraries that if you're manipulating especially large sets of data and real world data, then this is the one that people, repeatedly come back to. And yeah, so Pandas is, for those that might not know, is like a, data munging, data analysis library that lets you transform it. One of the hardest parts when you're doing machine learning is actually getting your data into a format that can be used effectively by your model. And so a lot of times real world data is pretty messy, or it might have gaps in it, or it might not actually be formatted in the right units. So it might not be sort of normalized so that you're within the right ranges. And if you feed the models just sort of raw data that hasn't really been either cleaned up or formatted correctly, then what you might find is that the model doesn't converge, or you get what seems like random results or things that don't really make sense. And so, spending this time and having a library that makes manipulating, especially very large sets of data, very easy, like Pandas, is super useful. And even just, for instance, like when I was doing that little demo there that we talked about, originally, when I started, I was feeding things raw pixel values for positions and velocities and stuff, and it just wasn't working. And it wasn't until I really normalized the data, cleaned it up, that I had started getting good, consistent results. So it's, dealing large scale data sets and being able to manipulate them effectively is super important.
Yeah, at the heart of all these successful AI things, these machine learning algorithms and whatnot, is a tremendous amount of data. It's why the companies that we talk about doing well are like enormous data sucking machines like Google and Microsoft and some of these other ones, right?
Exactly. And that's where the power of them comes from, is like, Google has access to like just massive amount of data that we don't have access to, regular people. Or like we were talking about earlier with like the radiology images, you do need a fairly large set of annotated data. And so that's data where, these are case files or whatever that, a doctor's already gone through and said, this one was a cancer patient, this one wasn't. And without that kind of annotated data, the models can't really learn. They need to know what the answer is, right?
Yeah.
And so
right.
That's really, really important.
Yeah, we have the whole 10,000 hours to become an expert for humans. That's kind of the equivalent for machines.
Yeah, I guess. Yeah, I don't know what the thing is. Machines might need more. That's one of the things that is really interesting about humans, is that our neural networks can learn remarkably quickly without having to walk into traffic 1,000 times or do something like that. And so there's some magic going on there or something.
Yeah, there sure is. All right, next up is Cafe and Cafe 2. And this originally started out as a vision project, right?
That's right. Yeah, Berkeley. And so this was primarily a vision project. And then there's a sort of successor that is backed by Facebook, actually, and is more general purpose and is sort of optimized for web and mobile deployment. So obviously, if you want to have machine learning based apps on your phone, then having a library that sort of targets that is pretty important.
Yeah, I'm sure we're going to see more of that. I mean, there are even rumors, I don't know how trustworthy they are, that the next Apple, maybe actually, did they announce this? That the next iPhone will have a built-in AI chip?
I remember that they just announced, so Apple actually just announced Machine Language SDK Core ML at WWDC in June. And so Apple is already targeting these sort of deployed ML models. So, in that library's case, you are effectively choosing a pre-made model. So I want image recognition, or I want, language parsing in my app. And then you can just feed these sort of pre-trained models. But it wouldn't surprise me, they've got the motion chip in your iPhone now.
Yeah, they got the motion chip. Yeah.
So it wouldn't surprise me at all to start seeing that phones are deploying AI chips in there to assist with this, because most of the sort of things like Siri is a machine learning based thing, right? So
yeah. Oh, yeah. And it doesn't make sense to go to the cloud all the time. Like, that's one of the super annoying things about Siri is you ask it a question and it's like 6 seconds later. Like, you ask it something simple like, what time is it? 10 seconds later, it'll tell you it's such and such. Like, is it really that hard? Yeah. It's got to go all the way to the cloud and you're in some sketchy network area or something, right?
Exactly. And so that I wouldn't be surprised to start seeing that stuff deployed onto mobile.
I think even at Build, Microsoft's conference, they started talking about edge machine learning, where like the machine learning is getting pushed to all these IoT devices that they're working on as well. So a lot of attempts in this area.
For sure, yeah. And that's the next big thing, right? Is like having IoT based machine learning devices. Like, can your fridge learn like your grocery consumption habits and tell you like you're going to run out of milk in 2 days and you're going to the store today, maybe you should pick some up. I mean,
it's going to happen.
Kind of crazy, but it totally will happen. Yeah.
Yeah, I mean, it doesn't sound as crazy as let's just let a car go drive in a busy city on its own.
That's true. And yet, but that's something that exists now, right? Like that's a thing. Like you can, and maybe it's not fully autonomous, but I mean, you could go and buy one like tomorrow. You could buy a car that you can turn on autopilot and like,
it's crazy. It's fully
it will drive for you. So yeah. The future is now.
The future is here. It's just not evenly distributed. This portion of Talk Python to Me is brought to you by us. As many of you know, I have a growing set of courses to help you go from Python beginner to novice to Python expert. And there are many more courses in the works. So please consider Talk Python training for you and your team's training needs. If you're just getting started, I've built a course to teach you Python the way professional developers learn, by building applications. Check out my Python Jumpstart by building 10 apps at talkpython.fm/course. Are you looking to start adding services to your app? Try my brand new Consuming HTTP Services in Python. You'll learn to work with RESTful HTTP services as well as SOAP, JSON, and XML data formats. Do you want to launch an online business? Well, Matt McKay and I built an entrepreneur's playbook with Python for Entrepreneurs. This 16-hour course will teach you everything you need to launch your web-based business with Python. And finally, there's a couple of new course announcements coming really soon. So if you don't already have an account, be sure to create one at training.talkpython.fm to get notified. And for all of you who have bought my courses, thank you so much. It really, really helps support the show. One little fact or quote from the Cafe webpage that I want to just throw out there because I thought it was pretty cool before we move on is they say, speed makes Cafe perfect for research experiments and industry deployments. It can process 60 million images per day on a single GPU. That's 1 millisecond per image for inference and 4 milliseconds per image for learning. That's insane.
That's so fast. And 60 million images per day is just it's crazy. And that's why, we were talking about the data just a minute ago, and the amount of data being poured into these models is just staggering if they're, every day. And I don't doubt that they're probably feeding, people are feeding these models that much data every day. And I think they were saying 90% of the world's data that's ever been created has been created in the last year. And so it's just one of these things where it just accelerates and builds on all this stuff. So I think these things are just going to get faster until they're effectively real time.
Yeah, absolutely. All right. I don't think we said the stars for that one. 20,000 and 11,000 forks. So up next is definitely one that data scientists in general just live on, and that's Jupyter.
For sure. And so this has just become the standard interchange format for sharing data science, whether it's papers or data sets or models, or this has just become the sort of standard, I don't know what you would call it, lingua franca for, exchanging this data. And it's effectively a tool for the thing called the Jupyter Notebook, which is kind of like a web pages with embedded programs and embedded data sets. I think that's probably a good way to describe it for those who might not have used it before.
Right. It's instead of writing a blog post or a paper that's got a little bit of code, then a little bit of description, then a picture, which is a graph, it's live and you can re-execute it and tweak it. And it probably plugs into many of these other libraries and is using that somewhere behind the scenes to do that.
Exactly. Yeah. It's built on the IPython kernel that's interactive Python kernel. Yeah, I'm sure that there are all kinds of specific uses that can run that notebook code and use that stuff there.
Cool. Next up is maybe one of the newer kids on the block in this deep learning story from Microsoft, actually, their cognitive toolkit, CNTK.
Yeah, and they just released, I think, the 2.0 version of it beginning of June or late May. And, now it's open source and it's got the Python bindings, and it's part of, Microsoft's been doing a lot of open source work lately, and they've been, really, really pushing a lot of their own projects. And it's like we said earlier, it's available as a backend for Keras. So it's similar, again, to TensorFlow and Theano, that it's again focused on that sort of low-level computation as a directed graph. So similar model. I think this is, obviously emerging as a popular and efficient way to represent machine learning models, is using that directed graph. So it's pretty popular too, right? It's got a decent number of stars and forks, and obviously as a Keras backend and Microsoft backed library, it's going to be pretty popular and pretty common out there.
Yeah, absolutely. These days, with Satya Nadella and a lot of the changes at Microsoft, I feel like this open source stuff is really taking a new direction, a positive one. And also, I think their philosophy is if it's good for Azure, it's good for Microsoft. And so this plugs into their hosted stuff in interesting ways, and they've got a lot of cognitive cloud services and things like that.
Yeah, Azure is becoming pretty huge. It's starting to rival maybe even AWS for a lot of this cloud hosted services, and especially around machine learning. Azure has so many different machine learning tools available, and it's really clearly a pretty pretty big focus for Microsoft. And again, it's great to see, more of the sort of big guns being more open about their development and sharing. I mean, it drives everybody forward and just accelerates development across the whole ecosystem.
Yeah, and they have a number of the Python core developers there. They have Brett Cannon, they have Steve Dower, they have Dino Veland. Like, there's some serious people back there working on the Python parts.
Exactly. Yeah, they've got a lot of the Python core team there. And I know a bunch of the guys from ActiveState were just at PyData in Seattle, and, huge number of the core team were there, and, just really, really great little conference there talking about Python and data science.
Yeah, I think they have some really interesting language stuff as well. So speaking of languages, the certainly the longest running one probably that's really still going strong is NLTK with 5,000 stars and 1.5 thousand forks.
Yeah, and so NLTK was like the natural language toolkit. And, obviously this is a thing for doing natural language parsing, which is, I guess, one of the holy grails of machine learning, is to get it to be really, so you can just speak to your computer in completely natural language, and maybe even give it instructions in natural language, and be able to follow your directions and understand what you're asking. And so this is like a really popular one in academia for research. They link to and include massive corpora of work. So that's like gigantic bodies of text in different languages and in different styles to be able to train models. So there's also like a pretty large like open data component to this project as well. And obviously, the use case here for natural language is, it's huge for translation, like we mentioned earlier. Chatbots, which are now a huge thing for like support. I mean, every website you go onto and it pops up, hey, I'm Bob, and can I help you today? And it's like not really a person, it's just a chatbot. And, there's just so many. And then, like we were saying, Siri and Cortana and all those sort of personal assistants where you can say, ask it a natural language question and it can come back to you. So this is the sort of almost like foundational library, still going strong, still tons of active development and research going on with this.
Yeah, it's really cool. And especially with all the smart home speaker things, Google Home, HomePod, all that stuff. This is going faster, not slower in terms of acceleration, right? We're talking more and interacting with them way more. Definitely the chat bots. And anytime you have text and you want a computer to understand it, this is like a first step for tokenization, stemming, tagging, parsing, semantic analysis, all that kind of stuff, right?
Yeah, and that's exactly what it outputs. So it will do is like generate parse trees and stem it all out, and then use the kind of tokenized version to use that to train your model, not sort of raw text characters. And we really are getting there. I mean, like these days, like for sure, like just the recognition part, the tokenization part is very, very good. It's more like the kind of semantic meaning. What do you mean when you ask it? You ask Siri for, what are the movie times for X or something like that? How specific do you have to be to get a reasonable answer from her?
Yeah, it's got to go speech to text, and then it probably hits something like this.
Exactly. Yeah, exactly. That's going to hit a library like this. And we're getting there. It's not quite at the Star Trek computer, do this for me, but it's like way closer than I kind of ever thought we would be. It's really pretty impressive sometimes.
Yeah, absolutely. It's fun to see this stuff evolve.
Absolutely.
All right, Pete, that's the 10 libraries, and I think these are all really great selections, and hopefully people have got a lot of exposure and maybe learned about some they didn't know about. And I guess encourage everyone to go out there and try these out, and if you got an idea, play with it with one of them or more.
For sure. They're also accessible now. You don't necessarily have to be ML researcher or a math wizard to actually create something that's interesting or experiment or learn a little bit. These libraries all do a really, really great job of abstracting away some of the more complicated mathematical parts. And, in the case of a lot of them, making it reasonably accessible. And so that's where I think you're seeing this kind of like democratization trend in machine learning now, where this stuff is becoming more accessible. It's becoming easier. And I think you're going to see a lot of creativity and a lot of innovation come out of people if they just sort of give it a shot and try something out and, learn something new.
Yeah, that's awesome. I totally agree with the democratization of it. And that's also happening from a computational perspective, right? Like these are easier to use, but also with the GPUs and the cloud and things like that, it's a lot easier. You don't need a supercomputer. You need $500 or something for a GPU.
Exactly. I think all of these sort of things feed in together where you have a democratization trend in the tools and the source code so that now, you can have access to Google's years and years of AI research via TensorFlow on GitHub. You also, like you said, can go and buy a $500 GPU and have basically a supercomputer on your desktop, but also this open data component where you can get access to massive data sets like the Stanford Image Library and these huge NLTK like language corpora that you can then use to train your models, where previously that was probably impossible to actually access.
Yeah, that's a really good point, because even though you have the machines and you have the algorithms, the data really makes it work. All right, so I think let's leave it there for the library. So those were great, and I hit you with the final 2 questions. You're going to write some code. Python code, what editor do you open up?
Well, obviously, ActiveState has Komodo, so I tend to use that a lot for doing Python code. But I've also, to be totally fair, I have used VS Code as well, which is getting increasingly popular. So I tend to like to cycle between them all because we have an editor product. And so, it's great to keep up to date on what all the other ones are doing. So I tend to cycle around a little bit, but yeah, like Komodo is sort of my go-to.
Yeah, that's cool. Yeah, it's definitely important to look and see what the trends are, what other people are doing, how can you bring this cool idea back into Komodo, things like that, right?
Yeah, for sure. Yeah.
All right, and I think we've already hit 10, but do you have another notable PyPI package?
I don't know. There's so many. I would again probably give a little bit of a shout out to, since we're talking about machine learning, to Keras, because I do think as an entry point to machine learning, it's so accessible. It's so easy to at least get started and get a result with. I would give a little shout out to that I think that if you're looking to get into this and you're looking to try it out, that's a really great place to start.
Yeah, I totally agree with you. That's where I would start as well. All right, well, it's very interesting to talk about all these libraries with you. I really appreciate you coming on the show and sharing this with everyone. Thanks for being here.
Thank you for having me.
You bet. Bye. This has been another episode of Talk Python to Me. Our guest has been Pete Garcin, and this episode has been brought to you by DataCamp and us right here at Talk Python Training. Want to share your data science experience and passion? Visit datacamp.com/create and write a course for 1 million budding data scientists. Are you or a colleague trying to learn Python? Have you tried books and videos that just left you bored by covering topics point by point? Well, check out my online course, Python Jumpstart by Building 10 Apps at talkpython.fm/course to experience a more engaging way to learn Python. And if you're looking for something a little more advanced, try my Write Pythonic Code course at talkpython.fm/Pythonic. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, Google Play feed at /Play, and direct RSS feed at /RSS on talkpython.fm. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Now get out there and write some Python code.